Okay, in this video we're going to discuss the product rule. The product rule is used for what it sounds. It finds products, right? It's a derivative technique to find a derivative when you're looking at a product of two terms, or they could be two polynomials, for example. Okay, they don't have to be polynomials, it can be anything, but for example. So the product rule, I'm going to go ahead and just write the rule down, sort of explain it, and as we do examples, you kind of see how it works. Okay, really straightforward. So the product rule here is if I have a product of two functions, so the derivative of a product of two functions, let's say these two functions are f of x and g of x, okay? So this is the derivative of the product of two functions with respect to x. It'll equal the first function, you'll just copy the first function as it's written, times the derivative of the second function. So you'll take the derivative of the second function, multiply it by the first function, and then you'll add, and then you'll take the second function and multiply that by the derivative of the first function. So you can think of it as being the first times the derivative of the second plus the second times the derivative of the first. Okay, that's literally the rule. Okay, but rules are kind of abstract and hard to understand unless you work in examples. So let's do some examples so you understand this rule. Okay, so my first example is going to be f of x equals 2x minus 3 times 2x plus 1. This is the exact same problem as the third question on the power rule review. Okay, the power rule video, that last question is the same as this one. You're actually going to see a different technique for getting the same answer. Okay, so let's go ahead and go over this question. So in this question, I want to identify the two functions that I'm looking at. Okay, I have one function here and another function here. So if I want this derivative, I'll copy the first function, it's the first, and then I'll take the derivative of the second function. So the derivative of 2x plus 1 using the power rule will just be 2. And then plus the second function, 2x plus 1, times the derivative of the first, which will also be 2, by the power rule. So it's the first function times the derivative of the second function, plus the second function times the derivative of the first function. Literally the rule, okay? So this derivative, if we solve it out, we'll distribute this 2, so this will be 4x minus 6. We'll distribute this 2, which will give me 4x plus 2. We will combine like terms, so it'll give me 8x minus 4. If you go back and look at the power rule video, that's the same answer we got, and this is a completely different way of doing it. Okay, so this is basically using a different rule to get the same answer. So there's usually in mathematics not just one way to do it. Okay, and people say, well, which way should I do it? Sometimes it just doesn't matter. Okay, you get the same answer either way. All right, some ways are shorter than others, and that's probably the way you should go if you can figure that out. But for the most part, there's no right way to do, or usually just not one right way to do something. So just keep that in mind. Okay, so we're gonna do another question now. Okay, so we're going to do another question here, number 2, for this particular review set for the product rule. So I have this function here, f of x equals x squared times negative 3x squared minus 2. So let's go ahead and do this. My derivative will be this first term, which is x squared, we'll just copy it, times the derivative of this term, the second term. So by virtue of the power rule, this will be negative 6x, that's it. Okay, plus the second term times the derivative of the first. So the derivative of x squared will be 2x. And then we just simplify this. Okay, so the product rule is actually pretty straightforward. Usually doesn't cause too many problems, but we're going to make this video anyway. So negative 6x times x squared is negative 6x cubed, and then we'll distribute this 2x all the way through there. So it's going to be minus 6x cubed and then minus 4x, like there. Okay, so if I simplify this all the way down, this is going to be negative 12x cubed by the looks of things, minus 4x. That will be your answer for this particular problem. Okay, so that's actually, yeah, it's not so bad, it's pretty good. And cool. Alright, so we're going that way, so we're going to do the next question. So this will be number 3. Alright, so we have here a binomial times a trinomial. Alright, we could multiply that out, right? And then just like the previous question, and use the power rule after we've multiplied that out and got that product. But that would be sidestepping the product rule. If we just have this product right here, instead of multiplying it out, we can still take the derivative even if we don't distribute everything out. Okay? That's what the product rule is for when you have situations like that. So let's actually take a look at that and work this out. So here I will take the first term, multiply that by the derivative of the second term. And it's thundering outside actually where I am. So we've got 2 times 2 is going to be 4x minus 6. Okay, that's got the derivative of the second term. So now we're going to take the second term, just copy the second term, which is this guy right here. Minus 6x plus 3. And then multiply by the derivative of the first term, which is just going to be a 1. Okay, and then we'll just simplify this by distributing. So this will be 4x squared minus 6x plus 4x, so minus 2x. Yeah, that's what it looks like. And then minus 6. That will be that. And this will just be the same thing. Multiplying by 1 doesn't do much. So let's actually simplify that out. Going all through these steps here, but we will combine like terms, so it will give me 6x squared minus 8x minus 3. And this will be my solution for this, okay? So as you can see, it's actually a pretty straightforward rule. Where it gets kind of complicated is when you combine that rule with other rules. That's where it becomes way more useful than just doing simple problems like this. But you'll see that in the future, and I hope that makes sense to you. All right, appreciate it.